Hi, I started recording this video on permutations and combinations and realized I didn't have my microphone on, so I'll start over. This lesson is about permutations and combinations. Now first, you're probably not going to see a permutation or combination question on the test. From what I've seen, they appear every other test, every third test, every fourth test, something like that. You'll have one, and it'd be at most one question. But then again, from what you're telling me, your last ACT test had 3 different reciprocal trig function questions, so you never know. You could have 3 of these things, I don't know. So for any permutation combination type question that they're going to ask for on the ACT, this does not include every type of permutation combination question. In particular, there's one type of question they could ask that they're not going to because it's too difficult for the ACT, but it logically flows from this. You may notice something missing here. It's because they're not going to ask that type of question. So we're just going to stick to the kind of things they could ask on the ACT. First thing for a permutation or combination type question, there's always going to be n things to choose from. You have a pool of things to choose from, and you're choosing 3 of them or 5 of them or some number. The number of things you can choose from, the total number to select from, is n. The number to select is k. The most trivial case here, can you repeat selections? Think of things like a password. Okay, you have a password with 26 characters. You can use only lowercase letters for whatever reason. It's not a very secure password, and it has to be exactly 10 characters long. How many different passwords are there? Well, in that case, for the first letter, for the first character, you can have 26 choices. The second character, can you repeat choices? Yeah, you could have A all the way across. That's another 26 times another 26, all the way 10 times another 26, which is equal to 26 to the 10th power. That's the base case. You have 26 letters to choose from, and you're doing it 10 times. You're selecting it 10 times, okay? And they can repeat. So those are usually pretty easy to spot, those kind of questions, and they're trivial. It's just going to be an n to the k power. So can you repeat selections? Does that even make sense to repeat selections? Sometimes they have something where it doesn't make sense, but it's not obvious, but you have to think about it and go, wait, that doesn't even make sense. If it's this type of problem, it's going to jump out at you usually. It's going to be something like this. So there you go. Next one, if you can't repeat selections, does the order of selections matter? Think of things like a foot race, where you have a first, second, and third place finisher. Can you repeat? No, the same person can't come in both first and second place. So you cannot repeat. Does order matter? Yeah, there's a big difference between first, second, and third place, right? At least in the Olympics. So that is a permutation. That's the definition of a permutation. You're selecting from n things, you're selecting k of them, and order matters. How many ways are there to do it? In that case, it's n times n minus 1 times n minus 2 and so forth, k times. Okay, we'll hit some examples on that. That's also denoted p in k. That's permutation in things and you're choosing k of them. Of course, not. I shouldn't use the word choose, say select. Selecting k of them. It's also n factorial over n minus k factorial. That's mathematically the exact same thing as this. Just for the ACT, this is probably an easier, faster way to think of it. They're not going to give you problems where you have 50 things and you're choosing 25. It's almost always you have 40 things, you're choosing 2 or 3 or 5 or something like a smaller number, and you can do that. You have more manageable numbers to work with on the ACT for the problems I've seen at least. I think that's because even if you haven't covered it in school, they want to see if you can deduce how to do it, but that's just me thinking maybe that's what they're doing. I don't know. It's also n with a p and a k, but these are permutations, okay? Let me write that on here. Permutation. Permutations, okay? If order does not matter, in that case, think lottery numbers. Let's say you're in a lottery, right? You're the state of Illinois and you have a big lottery thing going on, the big bubbles and the balls are bouncing all around and then some are going to pop to the top. Let's say you have 75 balls, 5 are going to pop to the top and they're going to be numbered and those are your winning lottery numbers. Does that matter the order the balls come out in? No, because they're just going to reorder them. They're just going to reorder those balls numerically, right? So if you end up with numbers of 2, 40, 10, 13, and 62, it doesn't matter if they show up in that order or some other order. They're just going to reorder it like 10, 2, 10, 13, 40, and 62. Those are equivalent. They don't matter. The order doesn't matter for a combination. In that case, there's a different formula. This would be n factorial over k factorial, n minus k factorial. It's the same thing as this, just then you divide by the total number of ways you can order these things, which is k factorial. In this case, it'd be 5 factorial, which is what, 120, I think? 5 times 4 times 3 times 2 times 1. Actually, it's not. That's, yeah, that's 6. That's 20. That's 120. Yeah, it's 120. So you'd have to just divide by the 120 in that case, because it's the number of ways you could, these same numbers could come out and they're all equivalent. So a combination is you have n number of things and you're choosing k of them. The order does not matter. You're just choosing k. So it could be lottery numbers. It could be people sitting on a committee. Doesn't matter the order they're selected. It's just those are the people sitting on the committee, that kind of thing. Okay. This is also called n choose k. If you see the word choose, that's a big hint you're dealing with a combination. Okay. It's also with parentheses, an n on top and a k down below, like a 10 and a 3. That means n choose k. That's a combination. And the formula is back over here. It's the same thing as this. The n times n minus 1 k times n, also divide by k factorial. It's also c with an nk. That's another way to denote this thing. And it's also an n with a big C and a k. These are all the same thing, all saying the same thing. So don't get confused. If you see one of those, they just mean a combination, okay? Let's get through some examples. How many 10-character passwords can be made with only vowels? A, E, I, O, and U. Pause the video, give it a shot, see what you think. Okay, ready? Can you repeat selections? In other words, for the first character, can the second character be the same as the first character? Yeah. You could have A all the way across as your password. Great, we're done. It's going to be an n minus k problem. Well, what is n? How many do you have to select from? Is that 10 or is that 5? Well, you're selecting from these guys. It's 5. K is the number to select. You have to select it 10 times. You have to make the first character, then the second character, then the third character 10 times. So this is simply 5 to the 10th power. On the test, they'd give you things like, is the answer 10 to the 5th? Is the answer 5 to the 10th? Is the answer 10 factorial over 5 factorial? Is the answer 10 factorial over 5 factorial times 10 minus 5 factorial? Basically all these different things, and then maybe they throw in some wild card in there. But there you go. It's just 5 to the 10th power. Let's move on to another one. You try this one. Let's say you have a padlock, and you can set the way to open this thing however you want, okay? Except for you can't have the same numbers repeat. That is, you could set the combination here to be 2, 30, 19, and that's your combination, but you can't have 19, 19, 19. That doesn't work, okay? Because the things, the inner gears of it will get all messed up for whatever reason on this particular cheap brand of padlock. So how many different ways can you set your padlock? Pause the video, give it a shot. Well, notice it goes from 0, 10, 20, 30, 40, 50. So the last one here would be 59. So how many numbers do you have to select from? 60. You're not starting at 1, you're starting at 0. So it's not 1 to 59, it's 0 to 59. So it's 59 plus 1, which is 60. How many numbers do you have to select? Well, you got to select 3 numbers. So can you repeat? No. Does order matter? Yes. 2, 30, 19 is not the same thing as 1932. 1932 will not open the padlock if the combination is 2, 30, 19, right? Order matters. Here you go. It's n times n minus 1 times n minus 2, which is 60 times 59 times 58, n times n minus 1 times n minus 2, k times k is 3. You have 60 choices for the first number, then you have 59 choices for the second number, 58 choices for the third number. That's it. How many choices is that, by the way? That's basically 205,320 if I did the calculator math right. And they would give you a bunch of numbers for this one, probably using different techniques. And, you know, they may give you 60 to the third power, then they give you this number, then they give you some other factorial thing. Who knows? I don't know. They give you a few different options, and that's the correct option. All right, let's try another one. And I'm not going to write out the whole question, but basically you have a 10-horse race. You're at Churchill Downs in Louisville, Kentucky. You have a 10-horse race. How many different ways can the horses finish in first, second, third, and fourth? Give it a shot. All right, can selections repeat? Can you have the same horse finishing in both first and second? No. So, does order matter? Yeah, first is very different from second. So here you go. How many horses are there? It's 10, so it's be 10 times 9 times 8 times 7. which is whatever that is. Apparently that's 5,040, but there you go. It's 5,040 different ways that 10 horses could finish in first, second, third, and fourth. Let's try another one. How many 8-digit numeric passcodes are possible? Let's say you have a phone. Normally it's a 4-digit one where you can choose from 0 to 9, and you have to enter your PIN, which is 4 digits. Suppose they want to increase security and make it 8 digits. How many possible passcodes would there be? Give it a shot. All right. Can you repeat numbers? Yeah. So what's the N, what's the K? So how many numbers do you have to choose from? Is it 8 or is it 10? It's 10. You're choosing from 10 different numbers. So you have 10 for the first one. Can you repeat? Yeah. So you have 10 for the second one. 8 times. In other words, that is 10 to the 8th power, which is, I think, 100 million. So if they just went from 4, which is what, only 10,000, to 8, that'd be 100 million different ways. That'd be a lot more secure, by the way, but whatever. Sorry I erased that, but let's go back to the same example. You have an 8-digit passcode that has to be numeric digits. Suppose you couldn't repeat the digits. How many different passcodes are there? Give that a try. You have 8-digit passcode. You can choose from any 10 numbers for each one, but they can't repeat. You can't use the same number twice. How many different passcodes are there? Can you repeat? No. Does order matter? Yeah. So, there you go. It'll be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3, I believe. Is that 8 times? 1, 2, 3, 4, 5, 6, 7, 8, which is, 3.6 million-ish. So if you can't repeat the same number, you only have 3 million different options to choose from. If you can repeat, you have 100 million. It's a pretty big difference, huh? By the way, this one may have been slightly faster using the actual formula here. 10 factorial divided by 10 minus k, which is 8 factorial, which equals 10 factorial over 2 factorial. You have a factorial symbol on your calculator. Entering in 10 factorial divided by 2 factorial is faster than going 10 times 9 times 8 times 7 times 6. So just know where your factorial symbol is. Sometimes you'll end up with 10 minus 10 or 20 minus 20 or something like that, and you have a 0 factorial. It's okay. Your calculator will know that 0 factorial is 1, but just know 0 factorial equals 1. If you really want to know why that's true, I have a link in the description below. Who knows, I may even put it right up here. I don't know. Go check out that video. That's the best one I've seen so far. I think he really starts to get into it like 55 seconds in or something. He gives a very intuitive reason for it. Then he gets into more mathy reasons and philosophical reasons why it's 1. But if you really care, otherwise just memorize 0 factorial is 1. But isn't 0 factorial the same as 1 factorial? Yeah. Tough duties, it is. Deal with it. So quick recap so far. If you can repeat selections, it's always going to be into the K for the ACT. There actually is, in the description below, you can read about it. There is a way where you can repeat selection, but order doesn't matter, and that's a very different ball of wax. So if you really want to know about that, but they're probably not going to ask you that on the ACT. I have not seen a question like that, so don't worry about that. Just know, hey, if you can repeat selections, into the K, done. Order matters, n factorial over n minus k factorial. Order doesn't matter, same thing, just also divide by k factorial. How many ways can you pick 3 people from a group of 6 people to sit on a committee? Give it a shot. First, can you repeat selections? Can you pick the same person twice? No. Does order matter? Well, in this case, they're just sitting on a committee. No, order doesn't matter. It's just you're just selecting 3 people to represent the group on a committee. So you're at a combination. That's going to be 6 factorial divided by 3 factorial, because it's 6 to choose from. You're selecting 3 over 6 minus 3 factorial. You could also do it the other way, which is 6 times 5 times 4, and then divide by your k factorial, which really is the same thing. These two are equivalent. So that's going to be, what is 3 factorial? It's 3 times 2 times 1, which is just 6. So that's 6 times 5 times 4 over 6. 6 is cancel. 5 times 4 is 20. There's 20 different ways you can choose 3 people out of 6 where order doesn't matter. If order mattered, it'd be 6 times 5 times 4, which is what, 120? But in this case, order doesn't matter. So Fred, Bob, and Joe is the same thing as Joe, Bob, and Fred sitting on the committee. Those 3 are sitting on the committee. There you go. It's only 20 different ways in that case. Let's try another example. This is a question that I've actually seen on an ACT practice exam. or something similar to this. You have 40 people at a party. Each one of them has to shake hands with every other person, but only once. How many different handshakes occur? See if you can do it. Okay. Can you repeat selections? In other words, can you shake hands with yourself? No. Okay. Does order matter? Well, how would you order this? How are you going to order handshakes? No. Think of it this way. You have 40 people. A whole bunch of people. You're going to pick 2 of them, and they're going to shake hands. Does it matter if Bob shakes hands with Susan or Susan shakes hands with Bob? It's the same handshake. Order doesn't matter. You have 40 people. How many ways can you group them into buckets of 2? How many ways can you choose 2 people from a group of 40 where order doesn't matter? Boom, combination. So that's going to be 40 factorial over 2 factorial times 40 minus 2 factorial. Now the 40 minus 2 factorial is 38 factorial. 40 factorial divided by 38 factorial, you're just left with 40 times 39, which is the same thing as this kind of thing, you know, k times, and then you're dividing by 2 factorial, which is 2. 2 times 1 is just 2. So that's equal to 20 times 39, because the 40 cancels with the 2, which is equal to 780. So there are 780 handshakes that take place. You can do this one intuitively as well. You can say, well, for each person, they have to shake hands with every other person. So 40 people you can choose from, then that person has 39 other people to shake hands with. Okay, that's fine. So it's 40 times 39. That's one way to think about it, but that is assuming that order matters. Order doesn't matter. It can go either way, so you have to divide by 2. Let's try a different example. Real simple one. I'm just going to say it, you solve it. How many 5-card poker hands are possible? You have a 52-card deck. You're choosing 5 cards. How many different hands, 5-card hands, are possible? Pause the video, let me know when you're ready. All right. Can you repeat cards? Can you choose the ace of spades 5 times? No. Does order matter? No. Doesn't matter if you choose 2, 3, 4, 5, 6. That's the same thing as choosing 6, 5, 4, 3, 2. The order at which you choose them does not matter. So here you go. That's going to be n factorial over k factorial and minus k. How many are there to select from? 52. How many are you selecting? 5. 5 factorial over 52 minus 5 factorial, which is, this is going to be 52 minus 5 is going to be the same thing as 47. I can't write. 47 factorial. So that's going to be 52 times 51 times 50 times 49 times 48, because the 47 factorials cancel. And this is going to be 5 factorial, which is 120, as we've seen before. So you'd run this through your calculator, and there you go. You could also just run this through your calculator. What's 52 factorial divided by 5 factorial, also divided by 47 factorial? And the answer is roughly 2.6 million. There are 2.6 million different poker hands you can have. Pretty neat, huh? I thought this was an interesting question I came across. How many binary strings of length 5 have exactly 2 1s somewhere in the string? Now, in case you don't know what a binary string is, binary is 0 or 1, right? So you have, like, in this case, one example could be 0, 0, 0, 0, 0. That's a binary string of length 5. It could be 1, 1, 1, 1, 1. It could be 0, 1, 0, 1, 0. It could be, you know, as long as it's just zeros and ones, 5 long. How many different ones can you have that have exactly 2 1s somewhere in the string? Like this one is an example. How many different ways can you do that? Give it a shot. Let me know what you think. Okay, I'm going to give you a hint just in case you're stuck here. Think of it instead this way. You have 5 boxes. How many different ways can you choose 2 of them? Because like choosing these 2 right here would be like this one and this one. How many ways can you choose 2 boxes out of 5? It's the same problem. Can you repeat selections? I don't even know how you do that. How does that make sense? If you're selecting this one, then you're selecting this one. You can't select that one twice. So does order matter? Does it matter if you choose this one first, then this one? Or this one, then this one? No. Order doesn't matter. Combination. What is n? 5. You have 5 to choose from, and you're selecting 2. which is also equal to 5 times 4 times, well, this is 5 times minus 2 factorial, which is just 3 factorial. The 3 factorial cancels with this factorial, and you're just left with 5 times 4, and then you're subtracting or dividing by 2 factorial. So this is just 10. 5 times 4 over 2 is 10. You could do this one intuitively, by the way. You could say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 ways. But if the question were changed to how many binary strings of length 20 had exactly 4 ones, you couldn't really do the finger thing very easily. But if you know the formula, you can do it. In that case, if we're 20 length 4, it'd be 20 factorial divided by 4 factorial times really 16 factorial, but it's 20 minus 4 factorial. It'd be 20 times 19 times 18 times 17 divided by 4 factorial, which is 24. So it'll be whatever that is. Let's try another example. Try this one. How many ways can you choose 3 different desserts for a menu of 10 dessert choices? Give it a shot. All right, can you repeat selections? Can you choose the same dessert 3 times? No. Does the order matter in which you select them? No, just you're choosing 3. Cake, pie, and ice cream is the same thing as ice cream, cake, and pie. It may make a difference in how they order them on your plate, because maybe you want a la mode, so you want the ice cream on top, you don't want the pie sitting on top of the ice cream, because that'd be kind of weird, but you know what I mean. So this is a combination. What is N, what is K? How many do you have to select from? 10. How many are you choosing? 3. So that's 10 factorial divided by 3 factorial times 10 minus 3 factorial. That's the same thing as 10 times 9 times 8 over 6, which is, you know, this guy just divided by 3 factorial. 3 factorial is 3 times 2 times 1. Okay? And that's going to be equal to, let's see, I can take the 3 out of here and the 2 out of there. So that'll be 10 times 3 times 4. It's 120. 120 different ways. How about if you were listing your top 3 favorite desserts in order? I want to know what your favorite dessert, your second favorite dessert, and your third favorite dessert is. How many different ways can you do that? Can you repeat? No. You can't choose ice cream 3 times if there are 3 favorites. But does the order matter? Yes. First one, then second one, then third one. In which case, it's just this numerator here, 10 times 9 times 8, which is 720. How did I do 720 so fast? 9 times 8 is 72. 72 times 10, 720. Just add a 0 on the end. Here's a neat one that we saw in one of your ACT practice exams. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 points on a plane. Okay? A Cartesian plane. 10 points. And no 3 of them are collinear. In other words, this right here is not collinear to these 2. This one's not collinear to those 2. This one is not collinear. They're only 2 at a time are collinear. You know, which by definition, you know, a line goes between 2 points. You can make a distinct line that goes between any 2 points. But you can't find any 3 of them that are in a line. How many different lines can you make going between 2 points? Give it a shot. Well, this is a weird one. How many total to select from? Yeah, it's most likely 10, right? How many are you selecting? 2. Well, can you repeat selections? In other words, can you have the same point twice? No, you gotta pick another. You have to pick one, then another. Does the order matter? Does it matter if you pick these 2 this way or these 2 this way? Doesn't matter. It doesn't matter. So you're down here. So that's gonna be equal to 10 factorial divided by 2 factorial times 10 minus 2 factorial. Seems like we run into the same number a lot, which is equal to 10 times 9 over 2, which equals 45. It's 45 different lines you can make with this. You work enough of these problems, you start to see, oh, this is just this many to choose from. Is this here? Then it's just a matter of, do they repeat? What does that even mean to repeat? Does order matter? Usually if it repeats, it's going to jump off the page at you. Yeah, you can repeat things like the password example, and you can repeat digits. Okay, great. It's going to be the number of digits to choose from to the power of whatever, how many digits you need. That's it. It's going to be, 10 to the 8th power or whatever. But if it's not obvious here, it's probably not that. Then it's just a matter of, does order matter or does it not? One final thing. If they put the word choose in the problem, it is almost certainly a combination. They're not going to put the word choose in there unless it's an in choose K type problem. that would be really confusing. I'd say 99 times out of 100, if they put the word choose in there, it's going to be a combination. Last thing, more of a trivial thing. You know how they call the combination locks? Even though the order matters, it should be called a permutation lock. Anyway, hope this helps.